So now we have got the perimeter. And this area, if we roll it again, if we join this point A and B again, that is, at these points A and B again, then you know that it will form our base, right? When we join our AB, it is forming our base. This. And if we are given our radius to be R, if this is R, then we can say that B3 plus B2 plus B1 plus B4 and all that is B1 plus B2 plus B3 plus B4, 5 till N, it is making this area. So we can say that half into L, and if we'll consider this to be R, then all this will sum up to 2 pi R. And we can write here 2 pi R. Now we can cut 2 and 2 and we get the CSA, that is this area, the curved surface area, as pi r l. So hence we have found out the curved surface area of the cone. That is by cutting it, then we have divided it into different triangles. We have summed over the area, since we have to find out the single. We have summed over the areas of single triangles. These, so we already know that this area is our curved surface area. So we have summed over. We know that given that this would give us the perimeter of the base, since when we join the 2 points, we'll again get the cone, and this outer part is forming the base. So now we have just put it in half into L in this formula, and we have just put it 2 pi r because that is the perimeter, and we have got this CSA of the cone. So our CSA is given by pi r L. Now, there is a surface area of a right circular cone. Now, to find the surface area, that is the total surface area. So, in previous slides, we have seen how to find this CSA, that is curved surface area. But to find the total surface area, all we have to do is that we already have the curved surface area, the CSA, and we have one additional circle. So, we'll just add the area of circle, and our radius is given to be r, so we have 2 not 2, it is just pi rl plus pi r square, right? And when we'll take common pi r, we get l plus r. So this is how we find out our total surface area, in which r can be written as, we can see that it is forming a right angle triangle with r as base and h as height, and it is forming a right angle triangle, and we'll use Pythagoras theorem to prove, as RL is given as the hypotenuse. Hypotenuse is L. So we can write L square, which is equals to R square plus H square, and we'll just put under root R square plus H square, that is given over here. So this is how we find out the flank height of the cone, which is given as L. So in this whole formulas, R is our base radius. Remember that R is only the base radius and cannot be taken from here or here or here. It is the bottom most part's radius, and H is the perpendicular height. So this is our height, and L is its slant height. Is this. Now let us do example. Now to we have the question is given to us that find the curved surface area of a right circular cone whose slant height is given 10 centimeter and base radius is 7. So we know that CSA of cone is equals to pi r l. Now pi can be written as 22 by 7 into r is 7 into L. L is 10. So cut it like this and we'll get 2 to 0. And since our lengths are given in centimeter, we'll write centimeter square. So this is our curved surface area of cone, an answer to this problem or example. Now let us move on to the next example. Example number 5. In here, we are given the height of the cone as 16 centimeter. and the base radius is given as 12 centimeter. So base radius means r is given as 12, and we have to find out the curved surface area and the total surface area. So the formula for CSA is pi r L. Now we're not given L, but we know how to find out L. L can be found out by taking under root of 16 square, that is our r square plus h square. So we'll take under root of 12 into 12 plus 16 into 16. Either you multiply, add, and then take out, which will be difficult, or you can do these mathematical, small tricks. Just convert the things that are in under root into perfect squares, and into product of perfect square and prime number. That is, 12 can be written as 4, which is a perfect square, into 3, and then 12 can also be written, another 12 can be written as 4 into 3, and then we have 16 is a perfect square already, but we can write as 4 into 4 into 4 into 4. Now we can take 4, 4, 4, 4 common, so we can get 4 into 4. So we are getting 4 into 4 as common, so we have 3 into 3 plus 4 into 4, right? So we'll take out, we have this in pair, so we can take out 4, under root 3 into 3 is 9, plus 4 into 4 is 16. So we have 4 under root 20, and we get 4 under root 25, and we have 4 into 5, which we'll get as 20, right? So this number is the square root of 20. Now we have got our L, we have our R, we have our H, we have all the dimensions that could be needed to find the surface areas of a cone. So first we'll find out CSA, which is given as pi. We can take as 22 by 7 into R. Our radius is given as 12, and our L height is coming as 20. Here we have been told that we have to take pi as 3.14. So I'll just write 3.14 over here. So when we multiply it, we'll get 7, 3. I'm sorry, we get 753.6 when you multiply it. Now our next thing is to find the total surface area. Total surface area is given by pi r L, not pi r, pi, it's pi r plus L, right? So now we'll just put on the value. So we have r as 12, and we have r, that is 12 plus 16. So when we do that, we get 3.14 into 12 into 12 plus 16, which is given as okay. Now this is L, so I have written the value of H over here. So our L is 20. So we have to, when we'll add, we'll get 32. Now when we do the multiplication, we'll get 1205.76 and centimeter square. So this is our total surface area of the cone. Now we have found out both the things, so our question is done. So we'll move on to the next question. Now in this question, we are given that a corn cob, here is our corn cob. So the corn cob is shaped somewhat like a cone. It is almost like a cone. So we can draw a kind of a cone over here. So I'll just draw it like this. And I'll measure all the dimensions that are given to us on this. So we have a cone, and the radius of its broadest part, that is our bottom, is given as 2.1 centimeter, and our height is given as 20 centimeter. Now if each 1 centimeter square of the surface area carries for average of 4 grains, find how many grains you would find on entire cob. So our 1 centimeter square has 4 grains. We have to find how many grains are there. To find that, we first have to find out the CSA of the cone, because we know that the grains would be found on the curved surface area of the cone. Now, to find the CSA, all we have to do is pi r squared pi r L, which is equal to our L is not given, so we'll just find it out. L is equal to under root r square plus h square. Our r is given, our L is given, our h is given, so we'll just do 2.1 square plus h is 20 square. Now this will give us the question, the that of this will come out to be 400 plus, and 2.1 a square would be 4.41. Okay, now we'll do this. We have 400 or 404.41 and under root. Now this is the square. When we'll take out the square root, we'll get 20.11 into 20.11. Now we can write it 20.11. So our L is given as 20.11. The calculation is a bit difficult, but you know how to take out the square root, right? So you can have this, you can do this question. And now let us see that, now let us find out the CSS, since we have found out that RL. So it was given as 20.11, which is equal to our L, right? So I just erase this out so that we have a space to do the question. Now we have our CSA as pi RL, and now pi is given as, since there is no mention of how we can take pi, we can choose either of 22 by 7 or 3.14. I'll take 22 by 7 since it makes our calculation easier. So 22 by 7 into r. R is given as 2.1 centimeter, and our length we have just found out is 20.11 centimeter. So we have 20.11. So when we cut it, we have 0.3, right? And then we multiply it, we get the answer as 132.726. Now we can round it off to approximately 132.73. Now this is our CSA given. CSA, and this is centimeter square. Now it is given that 1 centimeter has 4 grains. So 132.73 centimeter would have 4 into 132.73 grains. So when we multiply it, we get 530.92 grains. And since we do not have any half grain sort of things, so we'll approximately take it as 531 grain. So this cone has 531 grains in it, and you might be confused that why is it 92? And since we cannot have half grains, right? But you already know that these are real things, and you get the grains are small or big. Here we have taken that all the grains are small, are similar, but in reality the grains are small or big. So we can get 531 grains, and we can easily approximate without changing the real value of the cone.